Now, isotopes. Now, who can tell me about isotopes? Yep. Isotopes, they're elements that have different number. Is it okay if I use the number symbol for number? Everybody okay? I know it's a hashtag and you want to tweet as soon as you see that, but we're not tweeting anybody anything in this class. That means number. So it has a different number of neutrons. Now, this basically means that, for example, hydrogen has 3 different isotopes, which means it has 1 proton, but the number of neutrons are going to change, and we're going to get 3 different versions of it. Now, for example, the first one is this, and this is how you're going to see it. It's going to be a 1 and a 1. On this side, 1, 1, and H, the symbol for hydrogen. So H, this guy is your symbol, your element symbol. Do we know what the bottom number is? Nope. It is your atomic number. This guy up here, anybody know the name of this number? It starts with mass. Nope. It's called your mass number. So the top number is called a mass number. And the bottom number is called your atomic number, which is, what's the atomic number? What did we already define as the atomic number? Yep, that's the number of protons, number of electrons. So, our atomic number, we're not terribly concerned about the number of electrons. We're talking about isotopes. We're more concerned about the number of protons. So, even though, yes, it is the number of protons, number of electrons, this number, the number of protons, is what we are concerned about. Now, your mass number, I'll put it over here. The mass number is the number of neutrons plus the number of protons. Now, do a little bit of algebra here. If we're concerned with the number of neutrons and the atomic number, we know the mass number and we know the number of protons from the atomic number. what can we do with this equation to make sure that we can get the number of neutrons? Namely, if I say the number of neutrons is equal to something, what's it going to be equal to? Well, think of this as an equation. I want that, I know this, I know this. So if I'm adding that, if it's neutrons plus protons, how am I going to get rid of it and just get neutrons? Subtract. Just use some algebra. So I'm going to subtract that from the mass number. So it's the mass number minus the number of protons. Now, you can think of it like this, a different way. It's the mass number minus the atomic number. Or you can think of it as top minus bottom. So those are a few different ways that you can kind of think about this. Now, for the hydrogen one, where it's 1 and 1, this is the first isotope for hydrogen. This is called protium. How many? Let me ask you this. What's the number of protons? 1. There's 1 proton. What's the number of neutrons? Now, the number of neutrons is going to be the mass number minus the atomic number, or the top minus the bottom. So I'm going to take the top number minus the bottom number, and we get 0. Right here? Here? That's 1, 1, and that's an H. Since it's hydrogen. The first for hydrogen is what we call protium. Now the second one for hydrogen, which will look like this. 2, 1 with an H. This guy is called deuteronium. What's the number of protons? 1. Number of neutrons. Okay, how'd you get 1? 2 minus 1, which is 1. I want you to get into the habit of actually doing the math to get there. The third one is called tritium. What's the number of protons? How many protons do we have? We have 1. That bottom number is always going to tell you the number of protons. So that's your bottom number, which is your atomic number. No, because you guys will fall asleep. Some people are already falling asleep. Now, hold on a second. Figure out the number of neutrons. I got it. didn't change anything to it. All right, number of neutrons. How do I calculate that? 3 minus 1, which is 2. All right, now, for AG. Anybody know what AG is equal to? No. Silver. All right, here's an isotope of silver. Now, when you look at this and see this, I need you to be able to tell me what the atomic number is. Don't yell it out. Don't say anything yet. I need number of protons, number of electrons, and the number of neutrons. So you need to be able to look at this and say to yourself, all right, well, I need to be able to pick out the atomic number right off the bat. So what would be the atomic number? 47. Because remember, the bottom number here, that guy is your atomic number. So that guy's a 47. Now, if I know the atomic number, I should know the number of protons. So what's the number of protons? 47, because they're the same. And if I know the number of protons, I should know the number of electrons. What's that? 47. So this atomic number right here is the same as that and that. Those three things, four things rather, are the same. Now, for neutrons, how do I calculate the number of neutrons? Yeah, 107, the top number here, the mass number, minus the atomic number, which is 60. So for silver, we can figure that out. Now, if we went to a different isotope of silver, which is silver, which would be Ag109. So if you see this, you might see, and it's called Ag107, and this might be called Ag109. And what that does is it tells you that you have an isotope, and it tells you what your mass number is going to be. So in here, what's my atomic number? 47. It's still 47 because it's still silver. So silver has the atomic number 47. It has 47 protons and electrons. So protons and electrons is equal to 47. Now neutrons. What's the number of neutrons? 62. 109 minus 47, which is 62. So yesterday I said you need to add, subtract, multiply, and divide. Yesterday we did some stuff with multiplying and dividing when we were doing some conversion and all that. And now we're doing some adding and subtracting. Not too bad as far as the math goes so far. The biggest thing is you need to know where everything is, what everything is, and what they mean. And once you're able to do that, you're going to be in pretty good shape as far as everything goes. Yes?
What if you subtract the two numbers and get a negative?
You won't. You won't ever. because